All right, so we're going to be reviewing how to graph angles in standard position on the coordinate plane. And so an angle is said to be in standard if its vertex is at the origin. So if we look here, here's our vertex right here. And it is at the origin. So right here at the center of our x and our y axis. And so it says its initial side needs to be on the positive x-axis. So here's our positive x-axis. So that's where we start. And then in order for it to be a positive angle, that is when we go counterclockwise. So the same way that we number our quadrants, we go 1, 2, 3, and 4 is the same direction that the angles go when they are positive. Okay, so this is an example of a positive angle going counterclockwise. And so we have a clockwise direction is what is going to give you a negative angle. Okay, so if we were to go in the opposite direction, so if we were to start here and go around this way, then that would be a representation of a negative angle. The most common angular unit of a measure in degrees, which is equivalent to 1 out of 360 of a full rotation about the vertex. Sketch each angle in standard position. So the first one is going to be 120 degrees. So I am going to start off by labeling. Okay. When we label these, go ahead and start off here with 0 degrees. And here it would be 90 degrees. This one would be 180. 270. And then all the way around would be 360. All right, so now 120 is going to land in between 180 and 90. So we are going to put our terminal side there. Remember, our initial side always starts at the positive x-axis, and we are going counterclockwise. Okay. And then we are going to label this angle. We usually call our angles theta. So theta equals 120 degrees. Okay. All right. So we're going to do the same thing for the next one. We are going to graph negative 45. So we start at 0. This is going in the clockwise direction because it's a negative angle. So that would be negative 90. This would be negative 180. And then this would be negative 270. And this would be negative 360. All right, so the negative 45 is going to land in between 0 and 90 degrees. So it's going to land right in between there. And so we make a little arrow to show the direction that the angle is in. We call that angle theta, and we label it is equal to negative 45 degrees. It's not coming out. Negative 45 degrees. All right, for the next one. So now we have negative 210 degrees. So that means we're going to have to label going in the clockwise direction. So we start off with 0. This is going to be negative 90. This is going to be negative 180. This is negative 270. And then negative 360. And remember, our initial side, we always start at the positive x-axis. And then negative 210 lands in between negative 180 and negative 270. So it's going to be here in the second quadrant is our terminal side. And we start on the positive x-axis and we go clockwise. Okay. And then we label our angle theta is equal to negative 210 degrees. All right, next one, 400 degrees. So we are going to start off by labeling our axis again. That's 0. We're going in the counterclockwise direction because it is a positive angle. So 0, 90, 180, 270, and 360. Okay, but 400 is more than 360. So we're going to take 360 and add another 90 degrees. So if we add another 90 degrees, this ends up being 450 degrees, which makes this our initial side. We always start here. But we are going to end in the first quadrant because 400 lands in between 450 and 360. But when we draw our angle, we don't stop here. We have to go around once, and then we come up to the terminal side to show that it's 450 degrees. So then from there, we just label it theta equals 400 and not 50, 400 degrees, sorry. Right. Now we are going to graph in radian measures. So we're going to graph these in standard position. The first one is pi over 8. So we are going to label our graph. This time we're going to label in radian measures. So this is going to be 0. And then from here to here is pi. Okay. So that makes this line right here half a pi, or the same thing as pi over 2. And then down here is going to be 3 pi over 2. Okay, it's 3 halves. Okay, from there, this is pi over 8. So we know that from here to here is pi. We are going to cut this into 8 pieces. Okay, so that is 2 pieces. That would make 4 pieces. And so I'm going to cut all these in half, and that should make 8 pieces. Okay, that's 8 pieces of the pie. But we only want, remember the coefficient here is 1. So we only want one of these pieces right here. Okay, we start on the initial side, and then we stop at the first eighth. And then this would be our arrow right here. Okay. And then we label it, I don't have a lot of space, but theta equals pi over 8. All right, let's try the next one. So this one is 4 pi over 3. So we start off by labeling our axes. This is 0. This is pi. This is half a pi. This is 3 pi over 2. And I believe I forgot this one on the last problem, but once you come all the way around, this is going to be 2 pi. That is 1 full rotation. Okay, that's the same as 360 degrees, but in radians. So here they have 4 pi over 3. That means that we are going to cut this into thirds. We're going to cut it into 3 equal pieces. So we have 1, 2, and 3 equal pieces. But here they want 4 pi over 3, not just 3 pieces. They want more than that. So I'm going to have to make the other side of the pie. Okay, and then I'm going to have to cut it here so you can see it. And so they want 4 pi over 3. So we are going to start on our initial side. And then this would be 1 piece of the pie. This would be 2 pieces of the pie. This would be 3. And then last, this would be 4. Okay, so that's where we would end. And that is our angle right there. Now, we don't need to have all of this part. This part is extra. Oh, I didn't mean to delete this line. Okay, that part is extra, but that's just to help you understand when it's in radians, how we cut this into parts. And then we label it theta equals 4 pi over 3. All right, the next one, this one is negative pi over 4. So because it's negative, we're going to have to go in the negative direction when we're labeling our axes. So this is going to be 0. This is going to be negative pi over 2. This is going to be negative pi. I don't know what that's negative pi. And then this is negative 3 pi over 3. And then once you come in a full circle, that would be 2 pi. All right, so this is negative pi over 4. So we're going to do the same thing. From here to here is negative pi. Okay, this is in fourths, so they want us to cut it into 4 equal pieces. Okay, so there's our pi. We cut into 4 pieces. We only want, remember the coefficient right here is 1, so we only want 1 piece of the pie. So we're going to go from here, our initial side, up to here. And that is going to be theta equals pi over 4. Okay, so we really don't need this little section here, but it's there just to help you figure out which piece of the pies that you need. All right, and then the last one, it's negative 5 pi over 6. So here we're going to have to start off by graphing labeling our axes. So this is 0. This is negative pi over 2. This is negative pi. This is negative 3 pi over 2. And then once we complete one full rotation, that would be 2 pi. So then here we're doing negative 5 pi over 6. So from here all the way to here is 1 full pi. Okay, we're going to cut the pi into 6 pieces, 6 equal pieces. So that would be 2 pieces if we cut it in half. And then I'm going to have to split these into 3 and these into 3. Okay, so now we have 6 pieces, and we're doing 5 out of the 6 pieces. So I'm going to count. This is 1 piece. This is 2 pieces, 3 pieces, 4 pieces, and then 5 pieces. So then this is where we are going to draw our line. Now, if you don't like all the messiness, we can erase all these little pieces of the pie. This is our angle, and our angle is negative 5 pi over 6. All right. If you guys have any questions, go ahead and leave it down below in the comments, and I'll go ahead and answer you guys as soon as possible. That's it. Bye.